Welcome to the last part of vectors. In the first video, we looked at properties of vectors, vector geometry, addition and subtraction of vectors. In this video, we're going to take a look at position vectors and of course, column vectors and position vectors, and of course, geometric problems, which are paper 2 type of questions. So how do we add and subtract vectors? We talked of graphical ways, but here we're going to look at what are called column vectors. So column vectors, how do we add and subtract, and what are column vectors? So column vectors are vectors which are written in this form. Remember, on the graph, when you have a vector which is drawn, we could represent that vector by the x value and the y value. So that is also called a column vector. Usually, when we are working with vectors, we don't deal with the graphical part, we deal with non-graphical part. So when dealing with non-graphical parts, we have to talk about column vectors, which are written like this. So to add two column vectors, you just add the x values like 2 and 0 and the y values like 3 and -3. So in this case, you're going to have 2 plus 0 and 3 plus -3. This is just the same as the way we add matrices for those who have done matrices. So we're going to have 2 and 0. That's how to add vectors. Next, we're going to look at what is called scalar multiplication. Remember, a scalar has no direction. In short, when we're talking about vectors and you come across the word scalar, just know that it means a number. So scalar multiplication is to multiply a vector by a number. So for example, if you have vector a, which is this, then multiplying vector a by a number is what is called scalar multiplication. For example, we can multiply vector a by -5. So -5a means -5 multiplied by vector a, which simply means -5a means -5 multiplied by vector a. Vector a is 2, 3. So -5, 2, 3. So -5 by 2, it's going to give us -10. -5 by 3, it's going to give us -15. So that's what we get when we do a scalar multiplication. We just multiply the number outside the scalar with each of the numbers inside the column vector. Next, we look at position vectors. Position vectors are a column vector, but they care about, or they are more concerned with the position. So position has to do with where something starts to where something ends. So remember, when we were discussing this graphical method, we talked about this vector. For example, let's say it can be called OA, and this vector is going to be called OA, meaning that it starts from O and it ends at A. So this is basically what column vector is. So column vector shows you where it's starting, where it's ending. This is exactly what position vectors are. A position vector shows you where the vector is starting to where the vector ends. For column vectors, we showed A, just A as a vector. We were never concerned that where it's starting from to where it's ending. But for position vector, the way it is denoted, it emphasizes on where it is starting to where it's ending. It's starting on O and it's ending at A. So a position vector is just a vector with a known starting point. Usually, we use the origin O as the starting point. So its finishing point gives a position relative to that point. So this basically means its finishing point shows you where it's ending, and of course its starting point is, sorry, it's the last number, which is A, it's for the finishing point, and this finishing point shows you where the vector, how the vector is oriented. Okay, this point wasn't supposed to be emphasized on because it's not that important. What is important is a position vector shows you where a vector is starting to where a vector is ending. If they say OA, it means it starts from O and ends at A. And we usually use O as the starting point. So for example, this one is vector OA 2, 2, 2. So let's say we have these vectors, vector OA, this position vector OA 2, 3, and OB 0, -3. How can we find vector AB? So we know O, this vector starts from O and ends at A. This starts from O and ends at B. but they want us to find a position vector that starts from A and ends at B. So what we do when doing position vector, we are going to break this into two parts. The two parts are going to be somewhere these in a way, as you are going to see. So AB can be written as imagine you are at A and you're supposed to go at B. So when we're talking about position vectors, remember we know that there is O where everything starts from. So what we can do is we can start from A, we go to O, then we start from O, we go to B. So it can be AO plus OB. Okay, so let's picture three cities in Zambia. Let's say Kitwe, Lusaka, and Chipata. Okay, so if you want to go from Kitwe to Chipata, you go from Kitwe to Lusaka, then from Lusaka to Chipata. So A is Kitwe and B is Chipata, but O is Lusaka. So it's like Lusaka is where everything should pass. So going from Kitwe to Chipata, you have to go from Kitwe to Lusaka, then Lusaka to Chipata. Okay, so to go from A to B, you have to go AO plus OB. Hope you have gotten it using this analogy of Lusaka, Kitwe, and Chipata. Okay, so you should have AO somewhere. So if you look, do we have AO? AO is just the opposite of OA. AO is the negative of OA. What about OB? OB is this one which you have been given. So AO is just negative OA, but OB is the same. So when we talk about numbers, negative OA, it means all the numbers in here should have their signs changed. So this is positive and this is positive. They're going to be negative, both of them. If one of them was negative, it could have been positive. We just reverse the signs to show that we have added the negative. In short, you can see it to be negative times everything inside. So negative times 2 to be negative 2, negative times positive 3 to be negative 3, plus OB, we just write it the way it is. So additional vectors, we add the x values and we add the y values. So negative 2 plus 0 is negative 2, negative 3 plus negative 3 is negative 6. So AB is negative 2, negative 6. So don't forget this. AB is AO plus OB. If there was another question which was saying FD, then we could have broken it into FO plus OD. So always remember that there is O. So now we go to geometric problems. So we're going to take a look at key skills that are needed to deal with vectors. So the first are ratios. So given that a side is proportioned in the ratio like so, AB to BC is equal to 1, 2. That's how questions are posed when it comes to geometric issues. So AB to BC is equal to 1 to 2. So for you to find how AB is related to BC, what you do, you just do this AB over this AB you put 1 over it, and this BC you put 2 over it. So it will be AB over 1, 2, BC over it. So AB is the first 1, BC is the second 2. Okay, so with that you do cross multiply, this multiplied by this and this multiplied by this, you have this. So this is the relationship between the two vectors. 2AB equals BC, means that for you to have BC, you need to multiply AB twice. So if there were lines, if this is AB, then this is BC, because BC is 2 times AB. This is just visualizing. It's a very important thing to have when you want to see if what you're doing is correct. But what is important is this proportionating. The other skill is equal lines. Equal lines are represented by these. So if this line has another line which has this, so you have to know that they are equal. Then parallel lines are represented by arrows. So we can have ABC, we can have this and this. So this shows that AB is equal to BC. So another key skill is you have to make sure that you label all the sides whose magnitude is given directly or indirectly. For example, if we have this diagram here and they say OP is equal to P, so here it's better you label P. PR is equal to OP, so PR is equal to it's supposed to be P, not OP. Or actually, they have said PR is equal to OP. So here, the magnitude of PR hasn't been given directly, it's indirectly. So what you have to do is, what is OP? If you got OP, you see that OP is P, mean that PR is also P. So you put P here. Then another one is RQ is equal to 2OP. So OP again, this is indirect, is not given directly. So what is OP? OP is P, so you can put P here. So mean that RQ is 2P. So you can put between R and Q 2P. So be careful of direction. OP means moving from O to P. If they say PO, it's going to be negative of this. PR, it means moving from P to R. If they put RP, it's going to be the negative of PR. So these are the three important skills you need to have when dealing with vectors. So you forgive me, it's written accuracy. It's not supposed to be accuracy. Yeah. Anyway, that was just a mistake. With that, let's continue. So here's an exam question. In the diagram below, OA is A, OB is B, and AC over CB is equal to 1 over 2. So OB is B, OB is B, OA is A, and they have said AC, where is AC? AC over CB is equal to 1 over 2. So see what they want us to. The first question is express in terms of A and or B, AB. They want us to know AB. So AB, which is from here to here. So how do you move from A to B? How can you move from A to B? So to move from A to B, the rule of thumb is you have to choose parts that have magnitude given. Okay, if you haven't been given magnitude, then you cannot use it. For example, if you want to go to AB, you can use this path. Moving from A, can go to B. But here, what magnitude is this? They haven't given us the magnitude, so we cannot use this path. A magnitude is something like this. This is the magnitude of the vector, this is the magnitude, and the arrows show direction. Okay, another path you can use to go to B, you can use AM plus MC plus CB, but you don't have magnitudes. So the best path that you can use with which has magnitudes is AO. You go to A to O because there's a magnitude here, and then you move from O to B because there's magnitude here. So AB is equal to AO plus OB. AO plus OB. So what is AO? AO, this A here is for OA, not AO. So if we go opposite, this is going to become negative, so it's going to be negative A. Then going O to B, this one is in the same direction as the arrow, so OB is just B. So AO is negative A and OB is B. So this is the point. AO is just negative of OA, which is negative A. So and B and AB is B. Not AB, sorry. OB is B. So AB is going to be equal to negative A plus B. So it's a good practice to write down what you have found. So I've found that AB is negative A plus B. So I can even write in this direction, moving from A to B, the magnitude is negative A plus B. So that when finding other answers, if it is required for me to use this, I know that there's direction and it will be easy for me. So the next question is AC. 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 So how can you move AC? You can use here, but the issue is we don't have magnitude here, but we have the magnitude from A to B. This is where that relationship that given us comes in handy. So you can say AC is equal to, you can use the ratio to find the proportionality between AC and BC. One thing you can note is moving from A to B is AC plus CB, but we want to find AC. So you can use this relationship AC plus CB, which gives us AB, for us to know AC, since we know what AB is. So we're going to solve for AC. Okay. So here, solving for AC, we're going to have AB minus CB. Okay. So solving for AC, we're going to have AB minus CB. But we know the magnitude of AB, but the magnitude of CB and AC is the one we're trying to figure out. With that being said, we're going to use the ratio that we were given. That ratio is used in such situations where you have something given, but they want something for a part, or where you have something for a part, but they want something in full. Hope you have gotten the point there, but you're going to see the application. So the ratio we're given is AC CB 1 2. So we can solve for CB. Since we know AB, we're looking for CB. So we can solve for CB. Then once we solve for CB, what we're going to get, we're going to put here. So solving for CB, we're going to have 2AC is equal to CB. When you do cross multiply, AC times 2 is going to be 2AC. CB times 1 is going to be CB. So 2AC is equal to CB. Okay, so where there's CB here, we're going to put this 2AC. Okay, we're going to use substitution where the CB will substitute with the value I've gotten here. So when you do that, AC, this one is going to be AC equals AB, and there where there was CB, we have put 2AC. Now we again solve for AC. In short, we take AC this side so that we have like terms together. When we do that, we're going to have AC plus 2AC. AC plus 2AC is going to be 3AC. We can divide both sides by 3. We're going to have 1 over 3 AB. But 1 over 3 AB, AB we know is negative A plus B. So where there's AB, we can put negative A plus B. So we have negative A plus B. So that's how to deal with ratios. The part where you have been given something but you just need the portion and you have got a ratio, then make use of it. The last one, I hope, it's OC. 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 How do you move from O to C? So if you see there's nothing, there's no magnitude here, so we cannot use it. By the way, I've put here AC, which I'm from finding. So OC, you can move from O to B and from B to C. Okay? So OB, we have magnitude here. BC, we don't have, but we can calculate using the ratio. Since we know this negative A plus B is from B to A. Okay? And this one is just for this part here, A to C. So another direction you can use, you can move from O to A, then from A to C. Since we know what OA is and we know what AC is, which is this one. So that one is easier and it won't take us time. But even if you use this, you get the same answer, but it will take you time. With that being said, let's write it down. So OC is OB plus BA, which is the first OB, plus no, it's supposed to be BC, not BA. BA is from here to here. So another mistake here, a lot of mistakes there. Then another direction is OC, OA plus AC. Like I said, OC is OA plus AC. So I said 2, we can use OB plus BC and OA plus AC. OA plus AC is the simplest. So OC, OA we know from O to A is A. Then from A to C is just this. So we can say A plus this. So what we do is we expand the brackets so that we can put like terms together. So expanding the brackets is going to be 1/3 times negative A, negative 1/3 A, 1/3 times B, 1/3 B. Then these we can add. So we can just put over 1 here so that we view them as two fractions. Then we can add them, or we can subtract them, so to say. So when you subtract, we're going to get, I've skipped a step, sorry, but we're going to get 2 over 3A plus 1/3 B. So this is our OC. So what I've done, I've just subtracted like 1 over 1 minus 1 over 3. You're going to get 2 over 3A plus 1/3 B. So the question continues. Given that M is the midpoint of OC, given that M is the midpoint of OC, show that AM is equal to this. So given that M is here, is the midpoint of OC. So midpoint means it's in between OC. Okay, it's in between OC. All right, mean that from O to M is half of O to C. So they have said show that AM. They want us to find AM. So how can we find AM? Again, how do we move from A to M? We can use different routes. So we can use AM is equal to AC plus CM, where we move from A to C plus CM. We have AC, so it's easy. CM, we can use the fact that this is the midpoint, and we know what OC is. It is this one which we are from calculating. Okay. Also, we can use this path where we move from A to O, then from O to M. So it depends on which one is which. In this case, if you use this one from A to O plus O to M, I think it might be simpler because we just have A here, but here we've got, negative 1/3 A plus 1/3 B. So you need to do a little bit of work, and how to find CM and also how to find OC. OM, the effort is the same. So here for me, I might choose AO plus OM. It's simpler than AC plus CM. So choosing the second one, AO is negative of OA, which is just negative A. Then OM is half of OC. Okay, OC is 2/3 A plus 1/3 B. So it's half of 2/3 A plus 1/3 B. So we can expand the brackets here, multiplying this times this. It's paper 2, you have a calculator, so just punch 1/2 times 2/3 and 1/2 times 1/3. So it's going to give you 2/6A plus 1/6B. That's our OM. So now AM is AO, which is negative A, plus OM, which is this. So like terms, we can add them. So this is like negative 1/1 plus 2/6. Again, you have a calculator. You can just punch negative 1/1 plus 2/6. You're going to get, okay, me, I didn't want to punch. I had to show. Yeah, so I looked for a common denominator 6. You know what to do, how to do this. So 1 into 6. 6 times A, just like that, you're going to have this. But if you're the calculator, you can just punch since it's paper 2. So you're going to have negative 4/6A, but B here will still be 1/6B. Okay, but they've said it should be equal to this. That's what we're supposed to show. So when we have that, what we can do is, we have seen that B is on the left, A is on the right. So can we arrange such that B is on the left, A is on the right? So B, which is 1/6B, will be on the left, and negative 4/6A will be on the right. Now here we can factorize. We can factorize. So we can factor out 1/6. The first type of factorization, 1/6. So when you factor out 1/6, we're going to have this 1/6 will have B minus 4A. For me, what I used to do when I reach this level, I see that this looks near the same. I could just write this on the next step as the answer. It was wrong because sometimes if I've made a mistake, then the marker, the person who is going to do the marking could tell that this was just copied from here. But usually it used to work. So this is everything about geometric problems about vectors. They become simple as you solve more questions.